Hello and welcome to the first lesson in our statistics unit for Math 20-2. We're going to be looking at the first topic in S1, which is all about normal distribution. Now, to talk about how statistics can be normally distributed, first we need to talk about how we most generally represent normally distributed values. And so what we're going to do today is we're going to talk about the idea of frequency tables and histograms. Okay. So what is a histogram? Well, we've looked at charts, tables, ways to display data a bunch in our past math years, but specifically we're going to be focusing on histograms. So histograms are just like bar graphs. They're a specific type of bar graph that focuses on a frequency amount. So it tells us how many of our data points, right, of the whatever we're analyzing, fall into a specific range of data. And that specifically has to be a numerical range. This is going to tell us the frequency of each range. So essentially, how many data points fall into each range. So if we look at the images on the right, the first one is just a regular bar graph. It's telling us a comparison between some amount, right? It has a numerical amount up the side. But the bottom is categories, right? In this case, it's talking about countries, USA, India, the UK, right? And we can recognize that it's just a regular bar graph because there's gaps between the graphs. When we look at the histogram on the right-hand side, there's no gaps because instead of having categories down at the bottom, it's number ranges. So this is continuous data, right? Each range looks like it has a size of about 50, right? 100 to 150, 150 to 200. And so our data has to be categorized by how frequently, that's this value up the side, this is frequency, numbers in that range appear. So in the case of this histogram, it looks like about 21-ish numbers that fall between 100 and 150 appear in our set of data. It's important that this histogram is made up of this data, this specifically numerical data that we can count the frequency of, because that means that we don't have categories. And because we can't reorder number ranges. So the data in a histogram has to follow a specific shape in this case, right? We see that it's low at the start, and then as we move to the right, it gets larger, and then it kind of plateaus off. If we were looking at a bar graph, we can see a similar trend, right? Low at the start, peaks in the middle in the UK, down for New Zealand, high for Japan. But if I wanted to, I could rearrange these countries, and I could put the UK and Japan at the front, and then USA, India, New Zealand at the end. If I'm having number ranges, I can't reorder that. And so that's kind of the main point of histograms, is it's in a set order. So it tells us information about the graph as our numbers increase, right? As we look further to the right, as our numbers get bigger, is there still a lot of them? Is there fewer of them? What's happening? So let's look at an example to kind of see what this looks like. So you're shopping for new shoes and you find 10 pairs that you like, and you write down all of their prices. So we're going to organize this information into what we call a frequency table. And it's just a little chart that tells us the frequency of these numbers. To start off with a frequency table, we need to have different ranges so that we can find the frequency, right? I want to say how often do shoes between this price and another price show up. So the first thing we want to do is we want to identify our lowest value and our highest value. So scanning through my list of prices, it looks like my lowest price is $36. And it looks like my highest price is $74. So what this tells us is we're looking at shoes that range from $36 to $74. I want to know how many numbers we're spanning, right? How many different prices of shoes, right, we have to cover. So we can do that by finding the difference between the two. I'm going to take my largest and subtract my smallest. And so what this is telling me is I must cover, right, $38 worth of possible shoe prices. All right, I don't want to not include any of this data I've collected, but it also doesn't make sense for me to include data about shoes that cost $20 or shoes that cost $100 because we didn't find any of those, right? That's not part of our data set. Now we want to decide how big each range is going to be, right? Does it really matter if I'm talking about how many shoes are $36 to $38 versus $38 to $40? That's not a huge difference in price, right? If you were out shopping and you saw a pair of shoes for $36 and a pair of shoes for $38, you wouldn't really be too concerned about the difference in price there. The best way to kind of do this is to split your range into about 4 to 12 ranges, columns, bars, is the average size we kind of want for analyzing. We don't want a different range for every single shoe because, again, the difference between $36 and $37 is not a huge amount. But we also don't want to just have one big category, right? Because the difference between $36 and $74 is a fairly big amount. So I have $38 worth. And you kind of want to just use your intuition a bit here. If I split this into 4 categories, right, then I get about $10 per category, right? It ends up being a little less, right, 9 point something, but $10 for each range kind of makes sense, right? If you're talking about shoes between $30 and $40, and then shoes between $40 and $50, right, there's a good difference between those. Right, we generally, a little note, generally want our ranges, if we have big enough numbers, to go up by 1, 2, 5, 10, right? We want to go up by those nice whole numbers. Our brains are kind of geared to recognize patterns based off of those, right? If you're going up by $7, again, is there really a big difference between a pair of shoes that's $36 and $37? Not huge. So that helps me decide my range. And again, we don't need to start from our lowest number. My lowest price, again, was $36. I'm going to say that my first price range is between $30 and $40. I'm going to then say that my second price range, it has to be continuous, right? I can't skip anything in the middle, is from $40 to $50. I'm going to then go 50 to 60, 60 to 70, and 70 to 80. So we actually ended up with 8 different ranges that go up by $10 each range, right? That seems reasonable. You're talking about costs, right? $10 difference is a pretty good amount. That helps you kind of recognize the significance between the difference, right? $30 versus $70 is a lot. $30 versus $40, not a lot, but enough of a change to have some sort of impact. I'm now going to go through and I'm going to tally off how many of our values fall into each range. So looking at the first one, right, we're looking for prices between $30 and $40. Well, I see we have a 36, so there's 1. We have a 38, so there's 2. Right, the tally can just kind of help me keep count of how many I've covered already. The frequency of that is 2. the tally of $40 to $50. I have a 42, a 45, and another 45. So we see that there was 3 prices that showed up in that range. 50 to 60, it looks like I have a 51, and that's it. 60 to 70, it looks like I have a 62 and a 68. So that's 2. And then 70 to 78. And we always want to put numbers into the biggest range that they fit in. So this 70 is going to count not for the $60 to $70, but the 70 to 80, right? Always going into the largest bin it fits in. So 70 doesn't go here, it actually goes here. And we had a 74, which also fits there. So here's our frequency table. It tells us the frequency that prices in each range show up. We can convert this frequency table into a histogram. So when we're looking at this, we have our grid. Let's label things first. So I'm going to put the cost along the bottom. And each of these boxes is going to be one of my ranges. So this first box ranges from $30 to $40. As soon as we hit that next line, now we're at the range from $40 to $50. Then 50 to 60, 60 to 70, and 70 up to 80. So my cost is going to go along the bottom. Again, we're going to go from lowest to highest, and it has to be continuous, and it has to be a constant scale. Right? I don't want to say that I go from 30 to 40, and then 40 to 45, because that's not consistent. Up the side is going to be my frequency. Right? How often shoe prices in each range appear? And I'm just this time going to go up by 1 each time, because we didn't have huge amounts of data. So I'm going to graph this. 30 to 40, we had a frequency of 2. So I draw a bar that takes up the whole box that goes right up to 2. 40 to 50, we actually had 3 of these. So I draw a bar right beside, right? No gaps, no spaces. That's what kind of tells us the difference between a bar graph and a histogram. Goes all the way up to 3. 50 to 60, we had a bit fewer. We only had 1. Again, side by side in that bar. 60 to 70, we had 2. And 70 to 80, we also had 2. So now that we've turned this into a visual representation, we put a title at the top, price of shoes. We can identify what this graph tells us, right? Looking at this visual, I'm seeing a couple of things. I'm seeing that the most common price was $40 to $50. Right? Because we saw that's our highest bar. That means that it had the most values show up in that range. Our least common price was $50 to $60. Right? We only had a frequency of 1 there. And in general, there's no real pattern, right? It's not like we have more expensive shoes or more cheap shoes. It's kind of just an even spread. No bar is much larger than the other. Nothing's too crazy. Let's try another example. Here we have the weight in pounds of the Edmonton Eskimos football players. We want to organize this information into a frequency table and then create a histogram from that. So again, first thing we want to find our range. And we want to say how much data do we have? Our lowest, this looks in order, 165. Our highest, 335. the difference between those two, if I do 335 minus 165, is 170 pounds. Right, starting to think if I split this into sizes of 10, right, I'm going to have 17 groups. That's a little too many. I don't really want to split this into groups of 17 because that's not a really nice number. Again, that'd be like looking at 167 pounds, and then now all of a sudden 168 is a different category. I'm going to actually try and divide this. Again, thinking of those nice multiples, try something 10s, 20s, 25s, 50s. I'm going to divide this into sizes of 25. And that tells me I'm going to get somewhere around 7 groups, right? Depending on where I start or end, things might change a little bit. Right, we kind of just want to go with our intuition with those nice numbers that we recognize. And when we're creating this graph for other people to analyze, nice numbers that they recognize as well. So I'm going to go up by 25 pounds. Again, my first weight is 165 pounds. To make my numbers nice, round, and even, I'm going to put my first range from 150 to 175. And then I go from 175 to 200, 200 to 225, 225 to 250, 250 to 275, 275 to 280. Oh, sorry, not 280. My brain just started malfunctioning. 300, and then 300 to 325. Notice our highest weight is actually 335. So I'm just going to add one more row at the bottom. I'm going to go 325 to 350. So I'm going to calculate. I'm going to go through. I'm going to tally to help me keep count how many numbers are in between that range, right? Again, not including the highest number. 175 would fall into the second bin. So looking at this, our first number, 165 and 170, we only have 2 weights in that range. Because again, 175 all the way up to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 fall into that next category. Continue counting. Now we're going from 200 to 225. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we don't include 225 because that's part of the next bracket. 1, 2, 3, 4, 5, 6, 7, 8 here. Again, if you're not counting the tallies, you can cross them off as you go. That might help as well. 250 to 275. 1, 2, 3, 4, 5. 275 to 300, because 300 falls in that upper category, there's actually 0. And that's okay to have columns with 0. We want to make sure we're constant, right? We don't want to skip over a bin just because there's no values in it. 300 to 325, 1, 2, 3, 4, 5, 6, 7, 8. And then there was only one value between 325 and 350. So let's set up our histogram now. Again, putting my bin ranges, 150, 175, 200, 225, 250, right? And if things get too cramped, you can adjust your scale because we know that we're being constant. 250, 300, 350, and we know that it goes up by 25 each box. Our frequency, it looks like our highest frequency is 13. And we only have 1, 2, 3, 4, 5, 6, 7, 8 possible boxes. So I'm going to go up by 2s instead. 2, 4, 6, 8, 10, 12, 14, 16. Again, put your labels. So bottom axis is weight in pounds. Side axis is frequency. And that's what our y-axis is always going to be for these histograms, is how often did those points show up, those values. So here, between 150 and 175, we had 2. Between 175 and 200, right, this one got us all the way up to 13. So I'm going to go halfway between the 12 and the 14 for my height. 200 to 225. Now I'm going to go halfway between the 10 and the 8. 225 to 250, I had 8, so I'll go right to that line. 250 to 275, I had 5. 275 to 300, I had 0, so that whole column is going to stay empty. And then 300 to 325, we pick back up with 8. 350, 325 to 350, I just have 1. So again, this is a little messy on my digital screen, but we can see a few things about this, right? We see that there is, let's add some notes here. Oops. We can see that there is no weight between 275 and 350, right? We can see the most common weight for these football players is between 175 and 200. And we can see that on the edges, right, there's not really a lot of low weight players, and there's also not really a whole lot of high weight players. So take a minute, give this next example a try. Right? Try to record. If a student records the number of text messages they sent in a month, create a frequency table and histogram for this data.